What I plan to do now is maybe we will not have any break in between. We can continue, and hopefully I will be finishing it little earlier than 2 hours. So don't be worried. I plan to cover only the iterators, generators, yield, and a small part of exception, how it is used here. Just I want to give you the background of what is happening when the iterator function is called and how does it work, so that you will be useful for you to use it in your day-to-day for programming. Okay, so let us start off. All of us have used generators. The most important thing that maybe what we have seen is a generator range. All of you remember that. So that generates numbers in a given range, and then we take each value at a time, and then we go into a for loop, and then get one by one. So that's the simplest generator that we have seen so far. Range is a function. Now let us see if we understand the functioning of that and how we can implement our own generator functions using. Okay, yeah. Okay. So let us start off. What are generators? Actually, this link is gives you much more information about internal functioning of how a generator functions behave. Before that, let me first highlight what is it, and then I'll explain you a little bit about how it is implemented in the background. Python provides a generator to create our own iterator functions. Okay. Now, as I mentioned, for I in range 1 to 10. So this is what we have seen, popular one. So what happens here? We get a value in a range of 1 to 10, and this is inclusive and this is exclusive. So we get number 1 to 9. Now this function is a built-in generator. It generates the numbers in the range. Now how is it different from any other function? So what happens is, this is called first time when a for loop in a C function. We know that for loop is int I, and then I plus I less than some 10, and then we have I plus plus, then this. Then we know that this is executed first, and then this condition is checked, and if it is true, then this is executed. Then we know that this is 1, this is 2, then this is 3, then this is 4. Then it goes on till we compute that this is not true at all, then we come out. So that is the sequence which compiler understands and generates the code for doing all this one by one in an order. So that's how the C function for loop works, and that's the syntax of the for loop. Now what is the for loop of Python? This says that for I in the range, and then go into this. That means if this generates a number, something in integer, then we assign it to I. Carrying that value of I, we go into the for loop, complete it, and then we call the range again to get a next value, and then go ahead, go forward into the for loop. So when do we stop it? When this generator stops giving you the number. So in this case, it generates 1 to 9, and then it stops giving you more, then we come out of the for loop. So that means what? The range function, what we are using here, should know what are the numbers it has really already generated, because we are not calling it continuously. We call it first time, and then we execute some set of instruction. We come out and then execute something here outside the function, and then we again call this function to get another value. So it gives you 1, then 2, then it goes on till 9, and then when we call again with the hope that this is going to give me a number, because we don't know, there is no check here whether I is less than 9 or something. So this generator function is going to be called even when it has generated all the numbers it is supposed to generate. Then we call range, hoping that it is having one more number, and then it says, oh, I have already given you whatever I have, so I don't have anything to give you. Then it realizes that, okay, generator is not able to give me any number. Then we come out and then execute what is remaining there. So this is how the for loop here works, whereas here we have everything clearly mentioned, what is the condition to be checked, and then we this in this order it executes it. So if you see the difference between these two, in terms of implementation, let me erase everything. It's too many things. So let me change the color. Maybe I am bored of this color. So now for I in range 1 to 10 again, all and something something. Now what are we doing? We are calling this function range once, get a value 1, and then we are leaving it somewhere in between. The state of this is different from the the state in which we came here. When we came here, it was not even called, range was not even called once. But once we come into the for loop and then we iterate, we are iterating at the first iteration, we already called it once. Then when we are going to call it during the second time, it remembers that it was called earlier and gives you number 2. That means there is some state which is getting maintained in the range when we call this function. We are calling it multiple times, no doubt about it. We are calling, how many times we are calling? 1 to 9 and plus one more time. We are not even calling this much time, 9 times. We are calling 10 times. And then during this invocation, it is going to give something out saying that I don't have any number. That I don't have any number is normally given as a none type, and the for loop is structured such a way that this is a built-in for loop structure. So it has a way of checking it whether when I get a none type from the generator, it means that it has no other data to be given. Then I will come out and then do the rest of it. The for loop is done. So effectively, we need to have some mechanism of calling this method multiple times, but the method invocation needs to capture the information that it has been called that many times, and exactly not only that many times, which in which sequence it is there. The sequence is like this, and when it is last called, it should know so that it can generate the next number in the sequence. So effectively, a generator is a sequence. It generates a sequence, and then it also remembers the sequence, and whenever we call it multiple times. That means it is not that there is only one entry point, one exit point. There is a multiple entry point and multiple exit point for a generator function. So how is it done? Normally in a C function, when we call with some parameter, what is happening? We are calling it from the main function, and then a, some value we are passing. Now this invocation is like calling to another method, a call, some routines are there, as I mentioned, that parameters how they are passed, and then they are getting executed till it encounters a return. Now when it comes back, there is no state maintained in the function. That means this function will not remember that it was called earlier once. Then when I call after some time f1 with b, it is as good as calling it for the first time, and the entry point is the same. Exit could be different because based on the value, maybe you may exit somewhere. If I is less than 2, maybe you will exit somewhere. Exit point, maybe multiple exit point could be there, but the entry point is always the same. So in a normal C function, that is the truth. And it is as good as whether I am calling it here or maybe n number of times, the function does not remember or maintain any state that I was called earlier, unless you have a static variable inside and then you update it and you keep incrementing it or something. You will not know that this function was called earlier or not. That is not intended to be. And then and moreover, that is specific to the implementation, if I mention a static variable inside, but entry point is same. It is always going to execute from the beginning. Now what is the difference in a generator? A range function is different from the normal def that we have, some RAN rank something, and then we call. Here this normal function that we have in Python is also same as a C function. It comes here, and then if there is no return statement, at least it it doesn't expect a return statement. It puts a return none type, and then comes out. Otherwise, you may have some return in between and then it comes out. So it's this normal def that we do is a general function like a C function, whereas a generator function is different. Now, what is the difference? It remembers the when it is called, how many times it is called, and what is the state it which it was earlier went out, and then it starts off from the same state later on when it is called. That means it remembers the state. That means it remembers that it has generated 1, so that it can generate number 2, then 3. So some state information is maintained inside. In that case, the normal stack frame implementation of function call will not work if you want to do that, because as you know, in C or Python def, it will be using a normal stack. So when you call the function, it has a stack frame which is used for local variables and then maybe additional parameters that you have passed. And then if you call another function, maybe it will extend the stack frame, and then this is fn1. Fn1 is calling fn2, then fn2 stack frame will go like this. It will grow. When you return from fn2, this stack frame comes back, and then when you return from fn1, this also stack frame comes back. The stack is restored. Now, if you implement a generator function also using the stack frame, then it is not possible for you to maintain the state information about the invocation, because you need to preserve the stack frame of the invocation. Otherwise, it is not possible. But can I do it by implementing a normal stack and then hope to remember the state? It is not possible, because it has to be a contiguous memory, the stack what is growing. We cannot have some holes in between the stack, okay? Because I have used a generator function, so I need to go back here and then grow somewhere. It is not possible. So they are not implementing this using a normal stack frame. The stack of generator functions are implemented in the heap. Now, that means suppose if I am calling a range, okay, maybe 1 to 10, then a new heap space is created, okay? And how do they know how much they need? Because they know that what is the method, what is there inside, and then how much of space is required. The compiler can generate that information, and then it can allocate that much of heap. And then maybe if it needs to be extended, they may have some mechanism to copy this and then extend this heap memory. But if it is maintained in the stack is maintained in the heap. Now we have a flexibility. We don't need to give up the stack when you come out of the range function, okay? Because you are going to be calling it multiple times, so we need to maintain the state. So it will be possible to implement this kind of a generator function using a heap to store the stack for the function, okay? In that case, what happens is I can remember, if suppose I am calling it first time, then it will be maybe entering to the one entry point, which is the starting of the range function, and then it is going to read this value, or it is going to read this value and see whether it is possible to generate the number. Then it will generate 1, and then it will be somewhere in the middle, okay? It has to maintain some information. What is that information? When someone calls the range again, what is the entry instruction pointer, okay? Instruction pointer, IP, whatever it is. So where should I come in to execute further? So maybe suppose if I have implemented the range by a simple for loop like our C function for loop, I have generated 1, then I am going to increment it, and then I am going to call it again. So I will know that, okay, I have called it once. If I put it somewhere in the for loop, some instruction pointer, then it will come and execute this same instruction again. Now it will generate a number 2. So a generator function in Python has multiple entry points, and naturally always all functions may have multiple exit points, okay? One or many exit points, but in generator it could be a multiple exit point naturally, because when it is coming out at the end of the method, it is going to be the one exit point, whereas if it is coming during the middle of the thing, it is going to be different. So at least 1 or 2 exit points are sure to be there, and then multiple entry points are also sure to be there, because first time when you are calling it, first it is entering it. Unless this range doesn't have anything to generate, then there will be one single entry point and one exit point. Otherwise, you will have one or many entry point, one or many exit point. So every time when it is coming out and then being called again, it is going to maintain the information that where I am supposed to come back to execute the remaining instruction when it is called again. So there is a fixed entry point is not there. It is going to be variable entry point. So this is how it is implemented. In case if anywhere you come across some questions, you can actually explain this, and it will be useful for you to know how exactly it is implemented. Now let us see how do you make a function a generator. That's where the yield is there coming into play. This particular is not a capital E, okay. Yield is a small letter. Our PowerPoint has given it as a capital letter, okay, so don't get confused. So Python provides a generator to create our own iterator function. Now what is a iterator? Iterator is enabling you to go over a sequence, like a list or some sequence. It could be anything. I want to go through them one by one. Maybe I will take one and then process it. Again, I want to take one more and then I want to process it. Inside a for loop or a comprehension is another way of doing it. So we can do any one of them, but we need a iterator for doing that. So a generator is a special type of a function which does not return a single value. Instead, it returns an iterator object with a sequence of values. So what it does is, it is going to, is another object, an iterator object, okay, which is going to be useful for us to call it again. So first time when you are calling, it's like a normal method, okay, and then it is going to call a iterator. It's going to return an iterator object with some sequence of numbers. Next time I am going to call the iterator saying next. I am going to say next. First time I am entering it like I will tell you some iter function, okay, and then I am saying next time I am going to call it as next. That means I am call different entry point. This is the first entry point, iter, some built-in function within the class of iterator object, iterator class, and then it is going to do something differently to implement an iterator object like a function, okay. Range also is an iterator object, but it is a generator. It generates a sequence of numbers. Now the generator function cannot include a return keyword. Now the basic thing is, a generator function cannot have a return. If it is okay, it is included, then it would terminate the generator function. If it is included, actually, if it is, let me correct it. I don't know to, later on I may forget to change. Okay, so we need to have a yield to indicate that it is a generator function. In a generator function, a yield statement is used instead of a return statement. Yield is a keyword in Python. Again, it's a small word, a small letter. Okay, let me correct it. Okay, so it's used to return from a function without destroying the states of its local variables. Okay, that's why I said that it is going to be maintained in a heap. So whenever we are calling a generator function, a heap is taken, heap memory is taken, and the stack for that function is reserved. Okay, so when it comes back, it is still there available. So you can keep calling it until we say that the generator sequence is over, then this will be released to the memory. Okay, that's how it is implemented internally. And when the function is called in a sequence, the execution starts from the last yield statement. So if first time it is going to call, no, it is going to be executed from the beginning, but once it comes out with one sequence number, then next time it is not going to be in the entry point, it is going to come in the sideways. It is like a movie theater. When you come in, you come through this, but later on during the interval you go out and then you come in through something else, right? Come in into the theater with another entry. It's not that you need to come through only the place where the person is checking your tickets. So it is similar to that. When it is initially coming in, it will come in the first stage. It will check whether the range of things values is okay or not. Later on, it will be coming into the function in a different place at a different point in execution. So when the function is called in a sequence, the execution starts from the last yield statement. Okay, so there can be multiple yield, like multiple returns can be there in the function. So normally any function that contains a yield keyword is termed as a generator. Now what is iterator? Iterators are everywhere in Python. They are elegantly implemented within a for loops or comprehensions or generators. Iterator in Python is simply an object that can be iterated upon. Okay, that's what I said, that it is going to return an iterator object which I can use it to iterate over. So an object which will return data one element at a time. This is iterator is an object which returns one data element at a time. An iterator can be used to normally loop over the items in the iterable. Okay, iterable is the type of an object which can generate a, it's actually a sequence, and then it can generate some values every time when you call it. So the repeated passing of the iterator to the built-in next function returns successive items. So as I mentioned, first time we enter through some entry point, next onwards, whenever we want a next item, we call this next. Next is the placeholder for the execution. Okay, instruction, I mentioned about instruction pointer, which is nothing but an instruction pointer where it is supposed to start executing from inside the generator function. So iterator object is something outside and it is an interface to call the generator. So using the iterator object, the outside method is going to call the generator method. I want the next item, then it is going to help the outer function to call the generator and get the value that it wants in the next sequence. It is not going to be out of sequence. It is going to be giving you a number of values, like range is giving you from 1 to 9. It is going to give you the sequence. So when the item in the iterable is consumed from the iterator, so iterator, I said that it is the helper to access the generator to give the next sequence. Okay, but generator has the knowledge of how to generate the numbers, whereas iterator has the interface to make the caller to call the iterable or a generator function, which is an iterable object, to give you the next value. So now when the item in the iterable is consumed from the iterator, means all the items are consumed, it is gone. Not all the items, sorry. When you are actually taking out something, okay, suppose range is there, you have called once. Okay, once you call, you have already consumed one. That is gone. One is gone. Now next time when you call, you are not going to get one again. You are going to get the next value. So that's what I meant by it is gone. The first object is gone. Eventually, when no more data is available to retrieve, that means when you reach beyond 9 also you have consumed it. Now you are calling the iterator again because you don't know how long it is going to be generating. So we will be calling the range again, but when you have already consumed the value 9, it is not supposed to generate a value 10. So it is going to create an exception called stop iteration exception. Okay, that it will indicate that, okay, enough, I have done, generator says that I have done my job, I cannot generate any more data for you. So stop the iteration, it generates a stop iteration exception, which the iterator object, which is an interface that I mentioned, then it will come to know that, okay, all the items are consumed already, and it will inform the for loop that, okay, I don't have anything to give you, so go ahead and come out of the for loop. So that's how the protocol works, okay, between the outside function and the generator. Now, technically speaking, a Python iterator object must implement two special methods. Now, how do I implement it? Now, I have a generator. Generator is meant for generating the sequence. Okay, that only has the knowledge of what I should be generating it, whether I should say ABCD or 1 2 3 4. That sequence information or how to generate them is the knowledge is within the generator function. Now, what is the iterator object? It's like a guy who is calling the generator and then managing it. Now, first time when you are calling, it knows that, okay, I'm calling first time, then it is iterator object is coming out, and first time when you are calling the generator, then later on you are going to be calling the next method, which is going to have the intermediate entry points of invoking the generator to get the next sequence. And then when the completely everything is done, then it is going to say stop iteration exception. Then this object says that, okay, fine, job is done. This is the end of iterator. So that is what is the iterator protocol. This is how it is going to be talking to the generator. So an object is called iterable if we can get an iterator from it. So if we can get an iterator from it, then it's an iterable object. So all the built-in things what we know so far, all of them are iterable. So that's why we have been happily using the for loop inside them, using them. So most built-in containers in Python, like list, tuple, string, everything are iterables. That means what? The Python interpreter has already implemented these methods inside of those classes, which is helping us to do our for loop on getting those items from those iterable objects. So how is it going to be done? We'll see that. Okay. Now I'm going to, okay, this is maybe we should defer it. It's not right now required. Okay, let us now go ahead and look at the code. Okay. Any questions from anyone? I am not even asking that. You are also not asking me any questions. We are very quiet. You guys are. Okay. Now let me, these are all very easy things which you all know. So I am, not that you know, but I don't know, some of you may know. So I have all the built-in data types, list, tuple, set, and dictionary. Now, if I do a iter on it, okay, iter is generate an iterator object, okay. So I just want to tell you how these built-in data types are converted into an iterator object. Okay, that's I want to show you. They are all different iterator object. Now this is a list iterator, this is a string iterator, tuple iterator. They are all different objects. They are not same. Maybe they will all been inherited from the same iterator object, which they may not be. They may be derived objects, classes from the original iterator, but they are all specific to the data types. Now, why did they maintain a specific thing? Because when you call the next method on this iterator object, they need to be implemented differently for each of those types, because how you access a dictionary or how you access a list is different, right? And in fact, dictionary means you will go through the key to find out the next thing or no element. We use the implementation of those test list or a tuple or any of those different data types are different. So the objects are internally different, and when you want a next to be implemented on for all of them, we need to implement it in a different way. That's why they have defined these objects as a different iterator object, but they are all iterator object. That means you can actually call them in a for loop. Okay, so we will call them in one by one. Or maybe I will call all of them together. Okay, so because we are already aware of all these things, so there is nothing new to you. So this I am showing you just to say that if I want to know what is the iterator object which is coming out in this for loop, okay, when I am doing a for loop here, actually there is something about iterator object is coming out, so that this for loop can call it, but we are not doing it directly. We don't even bother about it because that is all internally consumed and used. So we don't even know that it is getting an iterator object, but it is going to be calling because we call it once and then we execute this method, this particular line, and then again we are calling it this iterator object. We are not calling the myString object, but we are calling the iterator which is coming out, and then it is going to give us the next character in the string. So now this is all very straightforward. What will be printed, all of us know. So let me run it once. We get all these values. Okay, there is no confusion about it. It is giving you in the same sequence because you know that in Python's 3.0 there is no random sequence of even the dictionary or set. So we get the same sequence is maintained, which I spoke about it. Okay, now let us look at this one by one. Now what I'm doing, I am having a dictionary and this needs to be immutable. Key has to be immutable. This value can be mutable. So I have put a list here. I am going to iterate over my dictionary. Now, does the iterator give out the key or the value of a dictionary? So that's the question I am asking you. Here I am printing I. Okay. Maybe I will show you the value which is getting printed. I'm sure you all know what is going to come. Okay, 1 2 3 4 is coming. My question is this one, is this one, or is this one which is coming out here? Anybody? Maybe I should see the chat window. I'm not okay. 1 second. Okay, don't worry, I am locally recording it. Okay, I have not recorded. Okay, thank you, Abhishek. You don't wait for me to look at your message. Okay, tell me if I don't see it. Thanks, Abhishek, for letting me know, but it's okay. I have a local recording. Okay, no issues. I am going to share the local recording only for this session. Okay, now I asked a question. What is going to be returning coming out from the iterator? Here, what I am getting as a I is this value or is this value? Okay, I am seeing 1 2 3 4, but I want you to tell me whether it's a key is coming out or the value of the dictionary is coming out. Anybody?
Sir, key.
Who is that? Sorry, I don't know.
Swati, sir.
Swati. Yeah. Yeah, Akash also said the key and you also said the key. Yes, you are right. Now, how do I know? How do I prove it? So let me show you that. Okay, there are many ways to prove it, but I'm just doing it this way. Even this is not proven for sure. Okay, new dictionary, I am creating it. Now, this also gives 1 2 3, but you will still be maybe confused because I have put this value here. No problem, but let me do it now to be sure that actually what we are getting is the key. Okay, so you are right, we are getting the key because always we search a dictionary only with the key, right? So the iterator also gets you the key only. Okay, that's a very logical one. But to prove that it is actually a key, I am going to use that what I have got from the dictionary to access the value. So if it works, then yeah, what you assume is correct, and you are right. So I am able to use the value, get the value using the key. That means what I got was the key only, not an item. That's why I just did not give you the clue that it is a key or a value. So I put an item there. Sometimes I become wise. Okay, now let us look at this now. What is happening? I have a my list ABCD. I am calling item. Now I am just showing you even a simple built-in um, data containers. Okay, I'll call it as containers now, more than the data type. It's a containers. How are we calling the iterator? Okay, because if you are using the for loop, we don't even know how it is getting called. So I am going to dig deeper into it and then call it using the iter object. So I am trying to get the iterator object of my list first. So this is the type. Okay, so I am going to execute it. So what am I getting? It's a class list iterator. As I mentioned earlier, it's a specific iterator for a list. So I have got a iterator now. Okay, now I am going to ask you another question soon. Not now. Okay, maybe now you can guess really. Okay, what are the values I am going to get? So as I told you in my PPT that we have to call iter first. We have called already. Okay, on this object I have called iter. Now remember, when I call iter on this object, this invocation of that call to the object is now in the heap of the stack of this invocation is in the heap. Okay, so I'm getting the iterator object, and then when I say next to it, it remembers where it was called. Okay, it remembers that the first invocation is already done, or it is actually first time I'm calling the next. Okay, in a normal flow, what will happen is iter and next will be called in the for loop first time. Here we are splitting it into two steps. So will I get the first element here or the second element here? Any guesses? If I print it, will I get the first element A or will I get B? Make a guess.
Sir,
B.
B.
B. Okay. Okay. So I don't want to say yes or no. Let us see what happens. I'm sorry, your guess is wrong. It is A. Let me explain now. Okay, it's very interesting. When we call iter on this, actually we have split the job of iter and next into two sequences separately. We are actually dissecting it and then calling it one by one. So here we have just created a iterator object once. That's it is a equivalent to for in a for loop. Okay, in a for loop, we are when you called iter, we are just here. We are not even come here. Okay, it is equivalent to calling the for I in my list or my new dictionary. I am here only. I am not even come inside. When will I come inside? When I get the first item, then only I will come inside. Now it is equivalent to the for loop saying int I equal to 0 and then checking whether I is less than something and then I plus plus, right? So we are in the first stage of calling the iterator object. So it has only generated an iterator object. It has not even tried to access the element. Okay, that is done only through next. Is sometimes you can implement it in a two different fashion. I'll show you that implementation. But here it is separately. It is next only is getting you the item. Okay, so this next actually gets you the first item in the iterator object. Okay, though it calls next, here it has only given you the iterator object. There is nothing like a tuple coming out with a new list comma some first item. No, it is equivalent to creating an iterator object. So maybe you might have thought that first iter itself should have given you the first object or a first element in the sequence, but it is not true. It is we are just generating the iterator object. Okay, it is the first level of what happens in the for loop. And then now you can imagine what is happening when you come in with the first item. It is both iter is called and the next is also called before you enter here for the first time. Now second time when you want to come in, only the next will be called. Okay, that's why I want to bring it to your notice that iter is called once and the next has to be called to get the first item, and then going forward only the next will be called. So that's how it works. So that's why I am dissecting it and showing you here. I hope it is clear. In case if it is not clear, please come online. So this is done. Now we know how to get those items. Okay, what happens internally in the for loop, this is what is happening. Now you may wonder who is calling these methods. It is the compiler. Okay, when it looks at this statement, it knows that you are interested in going over this iterator object in a sequence, and it knows that it is a built-in type list. So it has a next implemented and iter implemented. So I can call it in the order in which I need to be calling. So it calls that and then it calls the next, and whatever is returned by this next is assigned to key and it comes inside. Then it finishes off one. Maybe I will ask you to explain it, in a for loop, what happens, what sequence the iterator and the next maybe next are called in, explain it in, in a textual or in your own language, not the language of geeks and grey, geeks or whatever, the website. Okay, your own language, not from the website of language. So it is coming out like this. Now we have understood this much, hopefully. Now let us see what happens here. Sorry, I don't know whether you have already seen what I have written it. Okay, no problem. Now anyway, there is no surprise here. I have called 4 times I told that in a for loop, it doesn't know when to stop. Okay, it is like the child doesn't know how much is the money you have in ATM, right? When you say money is over, the child will say, "No, go to ATM and get some more money to give me buy me toys." That's what my son used to tell me when he was a kid. Now he doesn't do, but he doesn't know. This is a poor iterator doesn't know how many items are there inside, so it is going to call one more next in a normal sequence. So I am going to do the same thing here. So let me do that. Okay. For fifth time I'm calling because I'm mimicking what happens in the for loop. Now it says that stop iteration exception raised. Okay. So who is raising the this exception? It is the generator inside. It's not able to give you one more item, but you are interested in calling it, and that is what normally happens, and it is going to generate a stop iteration exception. Now somebody should be there to process the stop iteration exception outside, so that we don't see it when I'm calling it in the for loop. Why are we not seeing it? Because it is built into the for loop implementation that when I get a stop iteration exception quietly come out, rather than informing the user saying that, oh, the whatever list you have or iterable object you have is exhausted. It's not a major problem. It's you are also interested in finding out how many items are there. I want to run this for loop that many times and then I want to come out. So you are not asking it to go over the more than the numbers that are there in the iterable object. So it's not to be brought out to your notice saying that stop iteration has happened, exception has happened. But there should be some ways of informing the iterator outside by the generator to say that, hey, I am not having anything to generate. Please, handle it in your own way. So that is what is done. That the protocol is implemented in such a way that it generates a stop iteration exception which is handled by the outside program. Now why I am getting here, but I am not using it in the for loop. I am using it, I am dissecting it and calling it one by one. So I am supposed to manage it. So the best way of managing it is commenting it off. So I am doing it here. Okay. So this is what happens in an iterator. I hope this is clear. Now, having understood this, we are all ready to now implement our own iterator. Okay. Now, let me write how much time we have. Okay. If I leave it to you whether you want a break or not or continue. Continuing will be better because you will be hooked onto it. Tell me, okay, maybe another 5 minutes. You tell me whether you need a break now or we can continue. I promise you that I won't exceed 1 more hour. Okay, that's a gentleman agreement. Okay, now I am going to create a iterable object. Okay, I want my own object to be iterable in a for loop, like what I do for a list or a step setup or something. Now, how do I do it? I said that iterator object has a protocol that it needs to implement these two methods. These are all both are magic methods. We are implementing it. Now we are getting the object self. Now, as I mentioned, this is the entry point. Okay, I am making this class or the object of this class iterable by implementing these two methods. It's not one will not be enough. I will tell you the place where one is enough, but we will come to that at the end of the discussion. But for now, you take it from me that we need both, because I told you that first time it is going to call iter when you are calling it in the for loop, and then it is looking for a next to get the first item. Okay. Now, what is this method returning? I'm sure you know that it is going to return a iterator object, and then this is going to return an element in the sequence. Remember, these two are different. Okay, what they are returning is different. One is returning an iterator object, and then using the iterator object I'm going to call next. Then it is going to return the first element or sequence in it. In sequence could be anything. I can have a string or a another integer or a float or whatever. I may have some other object. I am free to have anything because I am implementing my own iterator object, so I can return anything I want. I can even have a iterator of function objects. Okay, so I can return function objects. So now how am I implementing it? I'm having a list. Okay, this class is going to have is I'm constructing a this object with a list. So I have a data list, and then I want, when I am calling this object in an iterator, in a for loop, I want to give one item in the list at a time. You may wonder that why are you not doing it with this data list, but I'm going that only out inside, but I want it to be captured inside an object, so I can do a iterator on my object. So I am making my object iterable. Okay, iterable object. So how am I implementing it? I am implementing it using a pop method. Okay, this method returns a one of the elements. Of course, you know that a list is a sequence. Okay, as I generate the sequence 1, 2, 3, 4, pop will return a 4 first, not the first element. Okay, so it comes in, it is checking if not self data list. Now, what is this? If I am, this is a, what is getting is a actually the object name, and then if I don't have a element, I am going to have a none type. None type is returned to a false, so it will return a no more element in the list. Otherwise, I am going to call a pop on the data list and then going to call that. Okay, now let me, how am I going to call? I am going to show you that. Let me take it this much. Let me first explain it how I'm going to call it. I'm not going to call it as, I'm doing it as a for loop only. Okay, now let us understand this. We have a my list. I have 4 elements in my just list, and then I'm passing it to iterable class. This is the data list, so I'm initializing it inside. So this is the list which is there inside the object. Now I'm calling it as a my iterator object. Okay, basically this is the object of this type, and then I'm going to call it over the for loop. That means I expect this object to be iterable. It's not one of the built-in data types, one of the built-in data containers, one of the containers of Python. It's my own object. It will become iterable if I have implemented these two methods. So it allows me to call it. So it calls. Now what is it going to do? As I mentioned, it is going to call this for the first time, and then it is also going to call the next immediately, because the first element cannot be got until it calls the next. So it is going to go through this and then pop the item. So first thing what I am going to get is a popped item of my list that I have initialized it with. So that will be the 4. Now it is in the for loop, and inside I have put a break. Now why did I put a break? I'm checking for the none. So before I execute it, I want someone of you to tell me, is it required or not? Or if I don't have it, what will happen? Anybody can come back, come online, or I will check chat window also in case if you are saying that anybody is typing it. So I think if I show chat window, you will not understand what I am asking. So let me explain again. We are constructed a object of my iterable object. Okay, I am calling it. As I mentioned, it is going to call the iter first once. It's okay. Okay, I'm not executing it for the purpose. I want you to really think what will happen when I'm calling it. And it is going to call next. And it is, as I told you, it's like a child. For loop doesn't know when this iterator object is going to say that I have no element. Okay, it doesn't know. Please remember that. I am not having any length or anything here. I don't even have that information. So I am asking you a question now. Why did I put this? If I don't put it, what will happen? If I don't have a check, what will happen? That's a question.
So when all the elements of the list are used, then again every time it will say that not self dot data list will be true, and then it will return none, and it will every time print none.
Very good. So let me check whether you are saying is true. This top iteration would have gone right. I have commented off, I think. Yeah. So let us run it now without the if condition. Let us run it. What you are saying is true. Next is getting called every time. No data item, no data item. This child is keep crying. I want more items, but sorry, I can't give you. Sorry, I have to put a control C here. So what has happened? As I mentioned, for loop doesn't know. Okay, how many items are there? As you mentioned, it is going to call multiple times, keep calling, and then it will go inside. This doesn't have an item, so it is going to print this and returns a none. But if I don't put this, it is going to be in the infinite loop. Now I have put this, so it will behave nicely. I'm giving a end. So item 4 has come, 3 has come, 2 has come, 1, and then it is going to call. Okay, it doesn't know the item has come to an end. The last call is going to be done, and during the last call it is going to pass a none type, and I'm checking it here luckily. So I break from the for loop. So I save. So this print is coming because once I am calling it, when the list has become empty, it will be called. Okay, there is no way unless you are feeding that information somewhere inside and then trying to do something which is not correct, because you are not supposed to do that. Okay, iterable object means it should be iterable really. Okay, as per the protocol. So this is how it is done. Now you may wonder that, oh, you said that I am generating an iterable object, but you are putting something to check it. Otherwise, it is not a complete implementation like what we have done for a built-in container. I agree to you that it is not the complete or a 100% implementation of a iterable object. Okay, we are going stage by stage to reach that. Okay, now I have a question whether can we continue or you want a break. I am okay for both, but I prefer that we can continue, but still I don't continue. Okay, I hope Swati will not get a beating from others. I hope others are also fine. Okay, okay, one more person. Okay, three. So Swati, you are not alone. Okay, so now let us implement closer to what we want. Okay, so let me take out other implementation. I will show you. Maybe I'll call that also. Okay, so this you know that is not a full information complete implementation. It's not a pure iterable object because I am putting something in between which I don't want. Let us see now what I have done. Same data list. Okay, iterator is same. Now what I have done, I try to implement something internal to my class. Okay, so that outside person is still is happy or not, we'll see. What I'm doing is next I am having um, what I do is I am initializing one index, okay, with 0. Then I check. Okay, actually I'm not solving that problem. Okay, basically I'm checking whether how many items I have. Then I am accessing it every time. Okay, if it is less than length, my index is less than the length of the data list, I am accessing it and passing it out as a data and then incrementing it. Now, as I mentioned, this next is like a generator. So it remembers the state. No, actually, sorry, it is not a generator actually. It is a next as like a method, and then because I am incrementing it, it has information which is captured as a attribute. Okay, it's not like a state information. Unless I use yield, this method is still not a generator. So I am capturing the state by maintaining an index. Okay, it's indirect way of maintaining the state. So when the next is called arraign, I am using I'm not using the pop method. Please remember, pop is taking care of popping it out one by one. But here I'm not using the pop. I am specifically accessing the data element and then passing it out. Okay. So now let me print what is, I'm just, this is all, nothing will be very specific. Now what is printed? Okay. Up to this point is printed. Nothing interesting is printed. Let me see whether anything interesting is there. Type of next what is the type of this. Okay, this is what I am printing it. Let me see. Guess the output of the below statement. Oh, I shouldn't have printed it. Okay, I should have asked you what is the output. Uh, okay, now this is what is the print, and these are all the output. Okay, now at least please. I should have stopped and then asked you for it. I ran it, unfortunately. Now, can you understand from this what is happening? Okay, let me come again. What I'm doing, I am finding the type of what is coming out from the next iterable object. Okay. Now, when I call the next over the my iterable object, it is calling the next here. So I get this printer. Okay, this is getting printed, and then mm, wait a minute. Where is, oh yeah, I'm calling it from this object, right, which is already exhausted. Okay, that state is already maintained. It is already no. Sorry. No, I'm not creating a new object, right? Iterator object, I'm not creating it here. This iterator object is same as this iterator object. That's why you see a print of this. Even this class is not there. Maybe I sorry. I should actually take it out and keep it there. Okay, that's a mistake I did. Okay. Actually, this is the place where it is supposed to be, because when I am calling here, I have not even created the new iterator object based on this implementation. What I am calling is with respect to the this iterator object, okay, which has been already called, more than 4 times. Okay, fifth time it called and then it came out here. Okay, that's where we are now. Let me execute it. Okay, now what am I getting? It says that I have no more data element. Now, why is it that I am getting twice? Because I am calling the next twice. Okay, one for getting the type of it. Another one is again I'm calling it multiple times. So here it is the fifth time it was called and then it came out from the break. And I am calling it the sixth time here and seventh time here. Every time it is going to tell me that I have already called my iterator object 4 times. Now it is going to give me no more data element. Okay, so that is what is going to come here, and I am getting printed here these values which is getting printed inside that. Now what is coming here? This is what is the print which is printing it. Okay, this is on invocation, and then when this print is called, remember, when the print is about to be called, all the parameters have to be computed, right, and then passed to the print, and then the print prints. So this is called first, and it is processing the input to the parameter from left to right. Okay, and then it is calling this. That's why you see these two printout coming, because next is going to be called and it is going to print saying that I don't have any element, no element. But what has returned by this next, which is a none type, is printed here. And it says it's a type is none type, and here it's actually a none type object which is going in. So you get a none printed here. So this two prints I wanted you to guess, but unfortunately I goofed up by not putting it in the proper place and then executing it again. So I hope you understand this sequence. If you don't understand, please stop me. Okay, now what I'm doing, I have done the same thing here, except the difference, any difference is there? Yeah, let me see. Instead of pop, I am using it here with proper index, so that I don't use that pop, because pop is giving me the values in the reverse order, which I don't like. I want it in the same order of the list. So I am implementing my own iterator using the next function without using any yield or any of the generator methods. Writing a normal method, I'm trying to maintain the state. Now, how am I maintaining the state? I am maintaining the state by keeping the value of the index inside, so that I know how many times this is called, so that the index value is preserved, so that I can call it when index is outside, within the, not in the this range, it is going to anyway come here. So it's not going to be incremented every time. Please don't mistake that it is going to be incremented every time. Once it exceeds the range of the length, it is not going to be updated, and it is going to remain as 5, sorry, 0 to 4. The 4 elements are there, so it will be coming out here. Okay, now let me call this function again. Okay, this function again with a different implementation of my iterator object. Okay, these are all different ways of implementing it. Now let us see. It works. Again, I don't like this break, but still I am at least happy that I could implement it in the same order. The objects are there in the list. I'm getting it. Pop was not the best method to use it. I have used it with the index and then started doing it. Okay. So remember, since iter is called first time, I have to do this. Okay. If I don't do this, what will happen if I call this? Okay. If I call the same iterator, okay, that's what 1a, you'll call it as 1a and 1b, and then I don't do this. Okay, just for demonstrating purpose, later on I will remove it. I don't do this. Okay, now what do you expect to happen? If I call, once I call is also okay. Let me do one thing. I will do sorry, index. Okay, now I have modified this, just demonstrate this. Okay, otherwise I will get a runtime error. Can someone guess? I'm calling the same iterator object only in another for loop. Okay, will I be successful in getting all the items here? If I comment off this one, will I be successful? Okay, yes or no?
So for the first loop it will be okay, for the second one it will not work.
Okay, what will happen in the second loop?
Because our index value is
Already
it
4.
is a class variable now. So for the next object, it will be incremented. It will be beyond the range.
Okay, good. So it is remaining as a class variable. It is not made into object variable. But okay, if that is the reason, I am calling it on the same object. I am calling it. That is not the reason I would say. But see, I am not changing the object name. I am not created another new object. I am using the same object. Is there a? Do you think that will there be any problem or not in that case?
It's a range.
Range. So it will be still having a problem. Okay. So now what is happening? See here. I have used the same object which has gone out of the range in the first invocation. Okay. In the first invocation, it has already accessed all the element. Next time when I am calling it, first time in the for loop, as I told you, it is going to call the iter once. It is calling it, and then it is going to call next again. Now, since it is already, the index is, as you said correctly, the index is already pointing at outside the range. It is going to just a print next. This is getting printed, but it is not going to return a value. It is going to return a none type. So I am breaking it from there. So I am not getting this 1b print at all here. Okay. So just to demonstrate that this is important, I have done this. Now what do you think? Now suppose if I have commented off, what would happen? Now that comment is removed. This I am initializing it on iter. Will I have proper iteration now? Yes or no? If I don't.
Yes, sir.
Yes. Okay. So now let me call it. 1b is called successfully. Okay. Again, iter is called. Next is called. Then all the items are called. So that is the reason we should put here, and we should reset back to 0, whenever iter is called, because we are aware that iter is called once. This is the best correct way of implementing it. Okay, you have to be careful that if you are not using any of those generator methods, and then you are trying to put a iterator using these methods, we need to be careful that we are resetting that every time on iter, because this is going to be called whenever a new for loop is initiated. Okay, so that is the reason I have put it there. Now let us look at another implementation. Okay, now let me take out everything so that we are a little faster. I need to stick to my time limit. I should not take complete 2 hours. You will hit me. Okay, now another implementation. This is little, I have to spend little more time to explain you what I am doing. I have removed the, okay, I have the index. Okay, sorry, I am not say that I have removed that. I have removed the checking for the and non-type, none-type. I have removed the checking for non-type. Now I am happy. My own iteratable object is also behaving like a built-in container. Okay, I am calling it. It's supposed to work. Okay, in the second iterator now implementation, without a non-type. I am not checking it. Now, how am I doing it? So let me explain. This implementation is same. Okay, what I have done is the same. This much is same. That means I am doing the index. I am remembering the index value using this object attribute, and then returning every time the data that I get from the list. And I will be happy to get this 11, 12, 13, whatever, 21, 22, 23. I will get it in the same order. Now, when I go out of the range, what I am doing here, instead of what I did earlier, I said none type, right? Because I was checking it there, so I was passing it. Now, instead of none type, I say stop iteration. So this is the protocol which I am explaining you by implementing it, that the iterator object, which is invoking my next every time, is waiting to receive the stop iteration from the next implementation. Okay, if it gets it, then it knows, okay, no point in calling this object again and again, no point in crying for a chocolate again because ATM is empty now, so I should stop going into the for loop. This is the exception. If I rise from my next implementation, then the iterator understands it and doesn't call you again. Okay, and because it is not going to call it again, and it stops and comes out of the for loop, I don't need to check for the for loop, the none type also. So let me run again. Now you see here, it works like a normal operator, normal iterator object, and it works fine, but it will be called. Please remember, after I exhaust all the elements, it is going to be called for sure. But only thing is, when I call the next, when the all the iterator, all the objects are being consumed, I am going to get a stop iteration exception, which is understood by the outside guy who is calling it, and it gracefully exits the for loop. So I don't need to anymore test my non-type here. Okay, this is a closer implementation of what I want to do. Okay, this is also a complete. Actually, I will not say closer implementation. It's a complete iterable object now. It behaves like an iterable object. I am not doing any test here like what I do here. So it's a complete implementation, I would say. But is it elegant implementation that you normally see in code? It is not. So let us try to do that now. Okay. Now let me comment. You can read it later. Okay. Now I am going to show you another implementation. Now you see. Now what is the difference you see? There is no index business here. Okay. I was not very happy with the index. Why? I already know the data item that I am sequencing through is already a built-in sequence. Okay, built-in iterator. Yeah, iterable object. So why should I use an index and remember it and try to use the length? All that is not a elegant way of implementing it. So what I do, okay, this is one more way. I take the data list. Okay, fine. I initialize it. Then I keep another object attribute saying data iterator, which I do it in init itself. Okay, which is a iterable object of data list. Okay, which I have to iterate over. Once I have a iteratable or iterable object in me, then when next is called, okay, when the next is called, what I do is I use the next on the iterator. Okay, remember, um, I don't know whether it is easy to understand. I am using the next on the iterator. Iterator is what? Not my original object. It is the internal data or the attribute on which I am iterating over. I have already got the iterator object of that. I don't need to compute it every time. So I compute it once when I'm creating the object, and then I use it for iterating over. Now, what is the advantage? This next gives me every time when I'm calling it the next element. Okay, because now I have passed on the um, responsibility of maintaining the state of calling this object, iterable object, to the implementation of Python. I'm not doing it here. I'm not doing that index, saving it or preserving it. I have passed on the responsibility to the this data iterator object, which is maintaining the state, which is in the its stack is in the heap, and then it is maintaining it. So every time when I'm calling the next, I'm going to get the next item. Okay, I don't need to maintain the state anymore in my class. I have passed on the responsibility to the built-in container. I'm using that built-in containers iterator, so I can pass on that information, responsibility to it. I don't need to do it. But what will happen when I exceed the limit? Again, the problem is it is going to give me an exception. It is going to raise an exception because again, this next doesn't know when the iterator is ending, the number of elements in that is going to be exhausted. So it is going to generate an exception for sure. Now, if I don't handle it here, it is anyway going to be coming out here, and I am to do something here. I have to do the same thing. But I don't want the user to be burdened with that because I did not do it. So I am going to handle that exception. Okay. Now I know if I exceed the limit, it is going to raise an exception, which I have put it into the try block. Okay. I have not explained the exception, but I am sure in Java or C, everything, this try block and the exception block is there. If an exception is to be caught, you need to have a try block, and then you say whether you are specifically looking for a particular exception. You have to say except and the name, or any exception coming from this try block, I want to be coming here. Then I come here and then I call stop iteration. I do this because I am creating an iterator object here, or I could actually pass the same object which is getting generated here, because it is also going to generate the same stop iteration object only. Okay, so I can capture that object and then raise it again. But why I am raising it? Because I want the outside iterator which is calling me the next to be aware of that I have exceeded the limit, or I have come to an end of the iterator object. So now this is going to again work as like it was earlier without any issue. I hope this is clear. Okay. I will now.
Excuse me, sir.
Yeah, go ahead.
Sir, not clear.
Okay. Now let me explain it. Let me come from the beginning. Okay. Now what I did, I have a data list which has been passed to me. I have kept it here, and I got the iterator of the list. That means I am going to use getting the next value from my list using the iterator. Okay, iterator object. Now on the iterator object, I can call the next. Then it is going to invoke one by one the element in the data list in the iterator object. Because it is a iterator object of this data list, it is linked. Okay, this actually accessing the original data list through this iterator. Okay, so I am calling that iterator which is stored in this object itself. Okay, using the next, that means it is going to call first time when it is called next, it is going to pass me the value, first value 31, next time 32, and when I invoke it after the 34 is called, I am going to call it again. That time it is going to raise an exception saying that no more data element. Now what is the exception? In this case, I am willing to receive any exception that is coming from here. I am catching it here. Then since it is I am implementing this whole thing for implementing my own iterator object, I have to raise a stop iteration because that is what is the expected exception by this for loop which is calling this iterator object. So I am raising this. Now actually I am getting the exception from here when the data element is exceeded, and I am raising that exception. Okay, specifically saying stop the iteration. Now once this for loop is calling this multiple next, okay, you see it is actually calling this next on this object which is nothing but this function, and inside of it I am calling the next of data iterator which is for this data list. Okay, so these two are two different iterators. This is an iterator for my data list, and what I am calling from here from outside is the iterator of my object. So this next is called by this for loop on every iteration, and once I come in, I am calling the iterator which I maintain it internally. Now why am I doing all this tamasha? Because I don't want to maintain the state information inside that index and other things I am not maintaining. Now I am calling the next of the self of data iterator which is now maintaining the state information, because this iterator is going to be maintaining the information till the list is exhausted, and then it is going to raise an exception when it is exhausted. Now when the exception is raised from here, I am going to be catching it, and then I am raising the exception which
Yes,
is
sir.
going to be
Okay.
caught here. Okay,
Thank you, sir. Yeah.
clear. Okay, I hope others are also clear. Let me see whether any more. Okay, no questions. So we are almost nearing, guys. If you have understood so far, you are very good. Okay, I am also very good. I'm happy. Now finally, I want to show you, before I use the yield, I want to show you what is yield. Okay, so some of you may be knowing it, but still for the benefit of everyone, let me explain the yield and then use it inside. Okay, that's the final implementation of the iterable object. Now I'm taking a detour little bit. What is yield? Okay, I have a slide. Okay, but I don't want to go there. Okay, we are in the code list. Yield is a, again, small yield. Yield is a keyword in Python that is used to return from a function without destroying the states of its local variables. And when the function is called, the execution starts from the last yield statement. Okay. Okay. Even if you not understood this statements, let us look at the function. I am writing a function print even. I want it to print only the even numbers in the list that I am passing. Now for loop, okay, test list. Please remember, now whenever you see a for loop and a list, you will now remember that it is iterator is called and the next is called, iter is called, all that you will remember, unwanted information. But I think you have understood now. I think it is okay. Like what is happening here, you will know. Then we are saying if I is mod of 2 is 0, that means it's a even number. I am passing it. Now I am not writing return. I am saying yield I. Now when this function, now what has happened, this function has become a generator now. Okay, Once I don't have a return and I have a yield, I told you that it's a generator. Now, similar to range function, you have your own generator function, which is print even, which is going to yield. Yield means it is going to pass. See, it's inside the for loop, okay, and it is coming in between the for loop. Remember, that means it was going through the list. Now I have my list like this: 1, 2, 3, 4. It came with value 1. This was not satisfied. Why 1 mod 2 is not satisfied, so it did not come to yield. It went again, picked up the next element from the test list, which happens to be 2. It comes here. Oh, 2 is mod of equal to 0. It comes here, yield. Then what happens is it returns the value 2 and remembers that I was here. I have come into the for loop. I did a 2 iteration already. I am here. Okay. Now, when the print even is called as next time, it is going to not call from the beginning, start executing from the beginning. It is going to start executing from this place where it left off. That means it has scanned through 2 and then it is going to be called again. Then it will again go back, take the 3, come inside. It will not come here. It will go back. It will take 4. Then it will come here and 4. Then it will come out again with a 4. So what will happen is, if I call twice, it is going to give me 2 and 4 in a sequence. So now I am calling it print j. Okay, this is the return value. Please remember. Now I am using it like a range. Okay, it's my print event has become like a range. It is going to give me values of only even, and I am going to take that into this and printing it here. So I get 2 here, I get 4 here, and then what will happen? So let us see. If you don't understand, let me know. There is no exception or anything. Okay, it just prints 2 and 4 and very promptly comes out. The reason why it promptly comes out, I'm sure you will be able to comprehend it or understand it. Okay, the reason being we are using the built-in, okay, iterator here, and here we are just using a generator. Okay, please remember we are using the generator, so it is not going to generate an exception here. What will happen is, let me tell you, when you call the print even, you are going to call it after the list is exhausted also. But what will happen is, it will come here, it will come again, it will invoke, but this guy is going to say that I have no more data, so it is not going to be yield. So it will be like a normal coming out of for loop. A function is is not going to maintain any intermediate state. It is completely called and given off. The hidden return is there, okay, below. So this function is removed from the heap now. Okay, it is no more. It's required. It's not maintaining intermediate state here. So it will come out forever, and finally it will come out of the for loop without any issue. Okay. I hope this is clear. In case if any one of you have any doubt, please stop me. Okay, finally I am ready to now to show you the final implementation, or most probably one before that. Final implementation is done. Okay, so we are nearing it. Okay, this is what is the, so far what we have done. We have implemented iterator object by different methods only to show you how exactly it is handled. Okay, I showed you everything to just dissect it and show you. Okay, now finally I'm going to show you something surprising. Okay, that we can implement the iterator object, okay, without using a next. Okay, that's a very surprising thing. Let me explain now. What is happening? Init is there, same thing what you saw earlier. I am luckily I am using the same data list. I am creating the iterator for it. It is there. Now I am implementing only the iterator, no more next. Okay, in this case, no more next. So, but I want to call it as an iterator object. Okay, iterable. It should be iterable. Now, how is it handled? Let me explain. First time I told you that this for loop fellow is going to expect this is an iterator object, and then it is going to call the iterator. Okay, as I told you, it is going to call looking for a iterator. This underscore underscore iter is there or not, because this class implements it. He is happy. This fellow is happy, and he is going to call it. Now, inside of it, I am calling. Okay, just printing it. I am maintaining a state, of course. I'll tell you the reason. And then I am calling the while loop, and length is less than the length. Okay. Now I am passing the bug of maintaining the state into this. Next I am calling. It is going to pass me the next data element. Okay. And length is getting incremented. Now yield data. That means I am getting the data, whatever I have on first iteration, I am sending it out. Now what is happening? I told you this for loop is going to call iter first and then going to look for a next. Okay, and then it is going to look for a next. But here if you see, the iter itself is not come out yet because I am in the yield state. That means iter is still executing. The first invocation that happens, iter is called, is still in execution because I did yield. When will I come out of yield? When I come out of the while loop, till then I am going to be in the yield. So next is not going to be called at all in this implementation. So I am using the yield here, and I am using the next of the iterator. So what will I have? What will happen is, it is going to give me, I'm going to invoke this multiple times. Okay, it is going to remember that I have called with that value. Okay, I am not using, please remember, I am not using the length to access the data list. Please remember, I am not using that. This data is not accessed using data list of length. Okay, length I am maintaining it for my own way of implementing it, so that I can come out of this loop, while loop, forever. Okay, once I am exhausted the list, so that I don't generate the exception. Okay, which I need to handle it either outside or somewhere inside. So that I am preventing it. Exception is not generated, but I am using next of this so that it remembers the values that has been called. So when the yield is happening, it is actually going to call it again. Okay, inside the while loop, not from the iter object. It is inside the while loop. It is going to be there because I came into the method and then I am inside another while loop inside the method. So this yield is going to make me execute within the loop. Okay, it's not going to call this again. So when I execute it, it is going to be very, very straightforward, and I'm not even calling the next again here. Okay, it is perfect execution. Iter is called once and it remains there. And it remains there. Okay, it's not even calling the next. Before itself, the whole thing is done. Okay, and we come out of this execution of the for loop completely. Okay, so that exception is still raised, but that exception is coming here. Okay, this next is going to create an exception and it is going to be caught here and it comes out. Okay, it's don't think that it is not there, but it is handled by this guy iterator. Okay, so next is going to be called multiple times, and when the but sorry, the length is there, right? So I am not going to call it again. Okay, length is less than the length, so I'm not going to even call it. I come out of this for loop, so it comes out without any problem. Whole thing is working. Okay, so this is one way of implementing it. I want you to try out different methods, and we are using the yield. Now we are using the yield inside a iter. Okay, now if I use the yield inside the next, we will have a problem. Okay, I will explain that before I end this. Okay, once again, this is the final thing I wanted to show you. Now, iterator next. Okay, this is how it is. The iterator object that we pass out is going to call this next. It returns the next item from the container. If there are no further items, it raises a stop iteration. As I told you, we know that using the yield in a function body makes the function a generator. Okay, we know that also. Now I am trying to link these two things. Okay, if I use a next, yield inside a next, what happens? When it is called, it returns an iterator known as a generator. Okay, when we use a yield inside a function body, okay, it returns an iterator known as a generator. Now let us compare the difference between the next and the yield. Next returns the item, next item, but a function containing the yield keyword returns an iterator. Now, consequently, using the yield in a next method results in an iterator that yields iterator. So, what happens is, if you suppose try to implement the same iterator using yield inside a next, you will get into an infinite loop. Okay, so to avoid that, we are using this method of not calling it. Okay, um, inside we are not even calling the next method at all. We are keeping it inside the iterator itself, method itself, and then executing it. Okay, please spend some time, um, write out different, try out different things. Maybe tomorrow I'll give some problem. I have to think over it, what I to do for the lab. Maybe using some iterator. I want you to implement some iterator. Let me think over it. Okay. Any questions before we stop? I held you for 1.5 hours. So please go through this. I'm sure you will be able to understand this difference between them. Iterator class is used to implement an iterator. Function is used to implement a generator. Local variables aren't used here. All the local variables before the yield function are stored in a heap, as I told you. Iterators are used mostly to iterate or convert other objects to an iterator using a itera function, which we saw that. Generators are mostly used in loops to generate an iterator by returning all the values in the loop. It uses both next and this, and not true always. We can use it only with iter. Generator uses the yield keyword. Every iterator is not a generator, but every generator is an iterator. Okay, that's a difference, which I have put a link also, Geeks for Geeks, so you can go through that. The working code is there. I'm sure you will be able to dig deeper into it and understand something. And if you have any doubts, please always drop me a mail, and we can take it up in the next class. Okay.